All right, so today we're going to start chapter 8. We're going to start with section 1, which the title of it is Sequences in Series. Okay, so we're just going to go straight to the definition. Okay, we're going to talk about what an infinite sequence is. And I took this definition from the book, but I don't like it exactly, so I want you to add the following. It says, an infinite sequence is like a function, because it's not a function. Okay, it's like a function. Whose domain is the set of positive integers. And I want you to highlight that sentence. That is the most important. That's really what tells you what a sequence is. Okay? The function values are ace of 1, ace of 2, ace of 3, ace of 4, dot, 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 ace of n, dot, 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 dot. Yes, sir?
So 0 is not.
0 does not include it. So that's very good. Okay? Which means that, okay, if your domain is the set of integers, that means that the only x values that you can input into this sequence is starting at 1, and then 2, and then 3, and so on. Okay, when you plug in, the reason why this is described as a function is I want you to think of a function. A function is something that where you can put an input or an x value and you receive an output, which is the y value. Okay, I don't want to call it a function because these are not going to be written in terms of x. Otherwise, we'll be talking about a function of x. We're going to be using the letter n so that you know that we're talking about sequences, okay? And really what I want to make sure that you understand is that with a function, you plug in an input and you get out an output, right? Well, it's the same thing. With a sequence, you're going to be able to put in an input, but you can only put positive integers into this sequence, and you're still going to get out an output, right? The output in sequences have a specific name. They are known as terms. Or the other way that I've heard this mentioned is that a sequence has a set of terms. That's the other way you can think about it, because you're going to get a set of solutions. Cool? All right. If the domain consists of the first n positive integers only, then the sequence is finite. Okay, so hold on just a second. So the top says infinite. The bottom one there says finite. So what's the difference? Can a sequence end?
Yes.
Yes. Does it have to end? No. So that's what it's trying to tell you. If you have a sequence, and notice the way that I wrote it. First term, comma, second term, comma, third term, comma, fourth term. Then there's a whole bunch of terms, and eventually there's an nth term, right? But then it can keep going. So if you have a sequence that keeps going forever, it's just known as an infinite sequence. But you could also have a finite sequence, which means that you can just have a certain amount of terms. That will be information that is provided to you, okay? So an example of a finite sequence would be like ace of 1, comma, ace of 2, comma, ace of 3, and I'm done. There will be no dot, 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 because the dot, dot, dot means that it keeps going. Understood? Yes, sir?
Would a set only would have no duplicates?
Would a set have no duplicates? I agree. You will not have duplicates here. It's just kind of like a function. Remember that when you put in input, there's no way that you can get two different outputs. So that's the reason why the word is like a function is used. It still follows a lot of those behaviors. Cool? Are we good so far with what a sequence is? Cool? All right, here we go. The very first thing I'm going to teach you how to do is to just come up with the terms of a sequence. So I am going to provide you a sequence, and you're going to find the terms. Cool? So in the first example, it says, write the terms of the sequence. Write the first 5 terms of the sequence. Okay? So that means you have a sequence, and notice how I don't have it in terms of f of x equals. I have ace of n. That lets you know that we're talking about a sequence, okay? If you want to find the first term, so ace of 1, that's known as the first term, all you got to do is plug in 1. So what's the first term? 3. Okay? The second term is what? 5. The third term, 7, the fourth, 9, and what's the 5? Okay, and the fifth is what? 11. The way you want to write your answers with sequences, is this finite or infinite? Finite. Remember how it's basically a set of values? Remember that there's a symbol for set? Here's how you're going to write it. Ace of n equals, what do we have? 3, comma 5, comma 7, comma 9, comma 11, and we close it. It's the set of those terms. Cool? Try 2, 3, and 4. By the way, you'll have a skills check on this on Friday. So if you're watching the video, please go ahead and pause the video and check your work. And now we're going to go ahead and move on. So notice how in examples 1 through 4, I gave you a rule. You came up with the terms. We should be able to do the other. I'll give you the terms. You come up with the rule. That is the challenging part about this unit. Okay? So I gave you some hints on this one. Number 5 and 6, you can for sure, anyone in this class should be able to do it. Number 7, I'm going to put an asterisk on that. That one is a difficult one. If you can't get that, I understand. I had to look it up. I couldn't get it the first time I did it. Okay? But look, number 5, we're going to do number 5 together, and then I'll let you try number 6. Okay? I even gave you hints. Find the nth term, so that means find the next terms, or find a rule for this in general. Look for patterns where you have n squared or n to the third. Okay, so that's my hint to you. So I'm looking at the terms on 5. It's like I have 3, 10, 29, 66. Okay. So what I'm starting to wrap my mind around this, and most people, here's what they do. Okay, so there's actually like a lot of games online where you play this type of games, right? Some people find it entertaining. Okay. Nerd. Whatever. Anyways, don't judge me. Here we go. Most people try to see like if adding something to each term would work, right? So that's like the first thing they do. So like, okay, so 3 plus 7 will give you 10, but then if you add 7, you're not getting 29. So I was like, okay, that goes out the window, right? And then subtracting will be the same thing, right? Like it's not gonna work. Then the next most people try is like, hey, let me multiply by maybe the same number, right? And then I'm like, okay, 3 times what is gonna give me 10? Okay, 3 times what is gonna give me 10? I mean, it's not a terrible idea, but then like I'm like, okay, but then think about it. Then I'm gonna have to multiply 10 by that number, and I can already tell, like, look at this. It's gotta be 3 times more than 3, right? Because 3 times 3 is 9. And if I take 10 times 3, that's already above 29. So I for sure already know that that's not the rule. Okay? So now, the next thought of this is using palettes, right? Like if I didn't have the hint, but that's what my brain would think, using palettes. Okay? So I'm like, okay, I know the first term, like that's the first one, right? And it's like if I would plug in the first, like 1. So 1 squared is 1. How would I get 3 after that? Plus 2, right? So 1 squared is a plus 2, right? So let's say maybe it's square plus 2, right? So for 2, if I put 2 in, 2 squared is 4 plus 2 is 6. It's not 10. I'm like, okay. All right, let me try the third power. So if I plug in 1 to the third power, I get 1. To get to 3, I'm going to add 2, right? So maybe it's n to the third plus 2, right? If I plug in 2, 2 to the third power is what? 2 times 2 times 2 is 8 plus 2? 10. Sweet. All right, we got something going on. 3. 3 times 3 is 9, times 3 is 27, plus 2? 29. So what's the rule? So a sub n is equal to n to the third plus 2. Do you guys saw the process that I utilized for this? That's the best I can do to help you. I can't get into your brain to get you to really see this thing. But did you guys notice like kind of the process of elimination that I did? First, I tried to see there was some adding. If that didn't work, I'll try to see there's some multiplying. If that doesn't work, try some powers. If that doesn't work, I'm going to show you more later of what you can do. But for now, let's just try those. Okay, so try number 6. Try number 7. I'll throw that as a challenge. Okay, number 7 is a challenge. Number 6 is also sort of a challenge because if you guys look at this, you have positive, negative, positive, negative. Okay. So pause the video, take a moment, try to figure this out on your own, and then we'll talk about them. Okay? All right, if you're watching the video, please go ahead and check your work. If you're watching the video, this was challenging to come up with, so this will only require for you to get some practice on this. Okay, so make sure that you practice it on the homework. Okay? All right, moving on. So flip the page. Here we go. Okay, another way that you can write sequences is known as recursive. Okay? To define a sequence recursively, you need to be given, so that's key. You are going to be given one or more of the first few terms. So that's going to be key here. They're going to give you either the first or the first 2 or the first 3 terms or so on, right? all the other terms of the sequence are defined using the previous term. So in other words, all the other ones will depend on the previous ones. Okay? And most of you guys really do recursive sequences all the time, but you don't know it. So for example, I can have a sequence right now recursively, like right now. I can say, hey, the first term is 2, and then the next term just add 2. So 2 plus 2? 4. And then to get the next one, just add another 2. 6. And then 8. Do you see what I'm saying? Recursively, like you're using the previous term. Okay? Yes? It gets tricky here in just a second because we're going to talk about 8.2, and something can be recursive and at the same time be arithmetic, which is what I just gave you, or something can be recursive and at the same time be geometric, which is what we're going to talk on 8.3. But stay with me, okay? So I'm going to give you an example here. It says a recursive formula is a sequence in one or more, if one of or more previous terms are used. This should be if, not in. Sorry. If one or more previous terms are used to generate the next term. For example, look at the first one. I am telling you that the first term is what? 1. And I am telling you that to find the next term, or any term in general, you need to take the rule a of n minus 1 minus 2. N minus 1. So if you have a value and you subtract 1, that means that you're basically going back to the previous term. Cool? So let me show you what happens here. So remember how I told you that the first term was 1? Okay? So that you need it. A of 2, according to this thing, if you plug in 2 in there, what's 2 minus 1? So it becomes a of 1 minus 2. Did you know what a of 1 was? Which was 1 minus 2 is negative 1. So to figure out a of 3, you're going to plug in 3 into the rule. So what's 3 minus 1? So that means you need a of 2. Minus 2. So what was a of 2? Negative 1 minus 2, negative 3. If you plug in 4, 4 minus 1 is 3. You need a of 3. Do you have a of 3? It's negative 3 minus 2, negative 5, and so on. That is known as recursive. When you're having to use the previous term to come up with the next term over and over and over again. There is a very famous recursive formula out there. Does anyone know it? Fibonacci sequence. The thing with Fibonacci is that you need the first two terms. But anyways, alright, I just showed you an example of how to do this. I want you to try number 8 on your own without me having to really show you one written down. So I'm telling you, hey, the first term is 4. And to find the next term, you need to do a of n, which is 3 times a of n minus 1 plus 5. So find out the first 6 terms. You got the first one, right? So you're really finding just 5. Okay? If you can understand number 8 without any trouble, go on to number 9 and number 10. Okay? Alright, so the first term was given to you, right? And if you understand that this is recursive, and you understand that that's saying n minus 1, that means that you got to use the first term to get the second one, right? So what are you going to do with this first term? Multiply by 3. What's 4 times 3? 12 plus 5? 17. And then to get the third term, you need the second term, right? So that, what are you going to do with the 17? 17 times 3 is 51. Plus 5, 56. So we got 3 terms, right? Okay. I believe in your number sense capabilities. Okay, 56 times 3. 168 plus 5. 173. Okay. All right. 173 times 3. Well. Wait, is it? I don't. It is? I don't know. 519? 500. Where were we?
And then you have 5. So 519 plus 5.
So 524. Okay, so we're on the 5th term, and how many did he want? Ah, crap. Another one. All right. So 524 times 3. So I know 500 times 3 is 1500, right? 24 times 3 is 70 what? 72, right? So 72 plus 150 is 1577. Sweet.
We all know that you
All right.
Well, I got it on here, but like I also want.
Questions on how to use recursive sequences? We're good? All right, so for time's sake, we're going to skip this. I'll put the answer. You can use them. Yes?
When it says find the first 6 terms of the sequence, do you count 4? I can count after you got to
1, 2, 3, 4, 5, 6.
But you use 4?
This is your first one.
Oh,
Yeah, because it's telling you, like here it says ace of 1, that's your first one. Cool?
So you won't get a 0.
All right. Yes. Where?
That's how.
Oh, this right here? I just skipped it, but look, if you plug in 2, you get 2 minus 1, which tells you to use ace of 1, which was the 4. And then times 3, and then the plus 5. Use the previous one. Cool? Alright. 9 and 10 are the exact same thing, guys, so just for time's sake, let's go ahead and move on. Which then takes us to the definition of what a series is. So we've talked about sequences. So before we move on to series, what is a sequence?
A sequence is like a function.
It's like a function
It's a set of positive
whose domain is the set of positive integers. Okay?
Yes.
So it's just a list of terms, right? That's it. Just a whole bunch of numbers that are listed as a set. Agreed? It can be infinite and it can be finite. Okay? All right. What if we add them? What if I take each one of the terms of a sequence and I begin to add them? That's what we're going to do. All right, stay with me.
What's the real world implication?
What
All right.
information are we
Yes,
gathering?
this actually has a lot of implication in the real world. Okay? All right, series and sequences are used throughout. Okay. Any electronic that is programmed to do anything for you uses an algorithm. And an algorithm is created thanks to a sequence. So really anything electronic that you use, you need a sequence or a series to come up with the mechanism of it working. Okay? In finance, I don't know exactly I'm not into everything, right? So like, I know that they're used in finance. And one of the biggest ones that I know of, but this is too advanced, like I don't even comprehend it myself, you guys know the concept of high definition. It's relatively modern, something that most of you guys enjoy. It has to do, and I can't pronounce it, there's some kind of sequence that starts with a G. I don't remember what it's called. And that sequence, or that series, is really the reason why high definition works.
Oh, the Ghirardelli.
Ghirardelli, whatever it is.
Ghirardelli?
No. No. It's
Someone just say chocolate.
No. Now you're making. Hold on. Now you gotta look it up.
Would you like to buy some chocolate?
You know what you make me feel like right now? You made me feel like. I remember one time. Let me pause this. The Ghirardelli series. Let's do this. Definitions of summation. So, a series is the following. Basically, here you go. If you take a sequence and you add up all its terms, that's what a series is. The addition of the terms of a sequence. That's a series. So what's a sequence? Sit back and read it. What is a sequence? Whose domain is the set of all positive integers. What is a series? The summation of all the terms on a sequence. Okay, so here's where things get tricky. So, we said that we had sequences that were finite, which means that you have a certain number of terms, and then you have something that is infinite. Agreed?
Yeah.
How are you going to add up an infinite amount of numbers?
Summation. You add the
And that's what you're going to learn in calculus. But first now, we're going to be dealing with finite. Okay? So here we go. So if you have, first of all, here's how you want to make sure that you understand this. This is how we write a series. Okay? We're going to use the letter sigma. Okay? The letter sigma means to sum. It means add. And it tells you that you are going to start at the first term and you are going to end at the nth term. Cool? So it's telling you, hey, add the first, second, third, fourth, fifth until you get to the nth term. Cool? That's all it says. So add the first, the second, the third, the fourth, and so on. Are we cool? Cool. I is known as the index, and it tells you where to begin. So the index, it's right here. It tells you to go from 1 to n. The upper limit of summations, this is the lower limit of summations. Okay? Here we go. We are going to find the sum of the following. You're going to be able to do this both in the calculator and without the calculator. So if I give you a problem like this without a calculator, you need to understand that this is telling you to add what? The first 4 terms. And you need to find them on your own. So let's do this. If I plug in 1, I get 5. And the second one would be 9. And the third one? And the fourth one? So 5 plus 9 is 14 plus 30? 44. So this is equal to 44.
You can also do like 5 plus 17.
Yes, sir.
For the answer, do we have to write out 4 over
The terms? Nope.
I equals 1 again?
No, you don't.
Just write 44.
That's fine. All right. 12. You have to pay close attention at where it tells you to begin. So you're starting at 2. So you plug in 2. So what's your first term? So 2 to the third power is 8 plus 2 is 10. So what's your third one? 3 to the third power is plus 2. Okay, so that's second. Now we got the third. We need the fourth and we need the fifth, right? Excuse me. 4 to the third power is 64 plus 2, 66. And the fifth to the third power is 125 plus 2, 127. So add them all up, and that's going to be your answer. 232? Sweet. Questions? Alright, so do we understand the difference between a sequence and a series? Can a series exist without a sequence? No. Cool. There are some properties that you're going to have to learn of series. Okay? It's telling you the following. Okay, so you have a series that starts at 1 and goes to n. Okay? C is just a constant. So if you just have a number, this is basically telling you, like, let's say that C was 2. That's telling you to add 2 plus 2 plus 2 plus 2 until you get to the nth term, right? Isn't that the same thing as taking that constant and multiplying it by n? That's a property that you can use to save time. Second property. If you have a constant in front of a sequence, okay, you can pull out the constant and then just deal with the sequence by itself. And then at the end multiply by that constant. Okay? Third one. If you have 2 things being added and it is as a series, you can actually split it up into 2 separate series and then just add up the results at the end. Same thing with subtraction. Do you have to know this? Nope. Can they save you time? For sure. Cool? Here we go. Here's the actual definition, the mathematical definition of a series. Consider the infinite series a sub 1, a sub 2, a sub 3, and keeps on going forever. The sum of the first n terms of the sequence is called a finite series, or, this is important in this vocabulary, you're going to see it a lot, nth partial sum. So if I tell you the 5th partial sum, that means I'm looking for you to add the first 5 terms. If I tell you the 10th partial sum, you're adding the first 10 terms, etc. Okay? Of the sequence, and it's denoted as follows. So we already know how to do that, right? The sum of all of the terms of an infinite sequence is called an infinite series. So that means that your index is going to go from 1 to infinity. And this one has some special properties that we'll talk about. Okay? We're good? Alright. Write the first terms of this series and evaluate. How many terms am I looking for in this one? So what's the first one? What's the second one? Third one? Fourth one? What's the sum? 50. Cool, so are we getting the point of this? Like how they work? And what this is telling you to do? Okay, which then leads me to the concept of factorials. Because factorials show up on sequences quite a bit. A factorial is when you use the exclamation point next to a number. This one you have to have memorized. There's a proof of this, and I honestly don't know the proof, so I'm going to be honest with you. Like, I don't know the proof of why 0 factorial is 1. I can look it up and put it on the hub if you're interested, but 0 factorial is equal to 1. Now, if you don't understand what a factorial is, you will understand here in just a second. 1 factorial is equal to 1, so you need to memorize that as well. 2 factorial is equal to 2, but look at how I got the result. 2 factorial is the same thing as saying 2 times 1. 3 factorial is the same thing as saying 3 times 2 times 1, which is 6. What's 4 factorial? Which is 24. Aren't factorials recursive if you think about it? Can I take 4 and multiply by 6 to get that? Can I take 5 and multiply by 24 and get? So isn't it kind of recursive? In a way, if you want to think about it that way. But, alright, do we understand the concept of factorial now? If it's the number, whatever it is, then you just multiply by all the integers all the way till you get to 1. Cool? Alright. There's a proof to it, and it has to do with calculus a little bit. I don't have it memorized.
Like factorial is like n minus 1 until 1.
Mm-hmm.
But then if it's 0,
No, you can still go minus.
oh yeah,
You
yeah,
keep
yeah.
going. Alright, guys, stay with me. Write the first 5 terms of the sequence given by this one. So this is going to see if you really understand what a factorial is, right? So if I plug in 1, 3 to the first power is 3, plus 1 is 4, so the numerator is 4, and the denominator is going to be what? 1, the first term. Second term, if I plug in 2, 3 squared is 9, plus 1 is 10, and the denominator is going to be 2. Third one, 3 to the third power is 27, plus 1 is 28, over, what's 3 factorial? 6, what's up? Oh crap, I didn't read the instructions. Here we go. So we can go back. It's okay. 0, if I plug in 0, 3 to the 0 is plus 1, 2, what's 0 factorial? 1, okay, so there you go. Fixed. Thank you, sir. Good catch. So that means I only need to find what? One more term and I'm done? So I'm going to plug in what now? 4. 3 to the fourth power is 81 plus 1 divided by 24, right? Because what factorial is 24? 4 times 3 times 2 times 1. So it is 24, right? Now, you're going to be expected to simplify things out on the terms. So that means that your final answer is what? 2, comma, 4, comma, 5, comma, 14 over 3, comma, 41 over 12. Can you divide by 3? No. Yes, sir. Mm-hmm. Yep. Alright, flip the page. We're almost done, guys, so stay with me. Alright, you got to simplify these things out. Dealing with factorial. So I'm going to give you an example, and then just looking at time, we got to get going, so I'm just going to show you the examples. So here we go. 9 factorial over 3 factorial times 7 factorial. Look at what I'm going to do. I'm going to rewrite this as 9 times 8 times 7 factorial over 3 factorial times 7 factorial. Why would I want to do that? Goodbye. What's 9 times 8? 72. What's 3 factorial? So 3 times 2 is 6. 72 divided by 6 is 12. Cool? Alright, number 16. I am going to keep that 3 factorial, but I'm going to rewrite that 8 factorial as 8 times 6 times 5 times 4 factorial over. I'm going to keep one of these 4 factorials so that it cancels out, but I'm going to rewrite the other one. Why? So I can factor out and cancel the other one. You guys with me? 3 factorial goes away, 3 factorial goes away. 4 factorial and 4 factorial go away. Alright, so the denominator is going to be 4. Alright, and 6 times 5 is 30. Times 7, 210. Times 8, so 210, 1680. Right? And then 4 goes into 16, 4, so 2, so 420.
420, what is it? Just 1. Or you could also divide 8 over 4. Where you have 8 times 7 times 6 times 5 times divide 8 by 4.
You can do that. Yep, absolutely. Alright. Are you going to really be dealing with this? No. This is me getting you to practice factorials, but this is what you're going to be dealing with. Sequences. Where you have n plus 1 factorial or n factorial. Okay, but this is going to show me what factorial is. So if I have 9, you told me 9 factorial is 9 times 8 times 7. So what are you doing for every term? You're subtracting, right? So look at this one. If you're starting at n plus 1 and that's your first term, what's your next term? N, because you're subtracting 1, right? And then what's your next one? N minus 1, n minus 2, n minus 3. But look, I'm going to stop here because what did I have in the denominator? That is equal to n plus 1. Cool? Alright. That's everything that needs to be covered on this unit. And that's how you do it by hand. Now I'm going to show you how to do the calculator with all this. Ready? Grab your calculator. Here we go. Alright, guys, these notes are super old. I've used them for a long time. So your calculators are different nowadays. And it's actually a little easier. So stay with me so that you can know how to use these calculators that you have. Okay? Here we go. So it says, to evaluate the above sequence on a calculator, the following would need to be entered. So let's say we're going to have a sequence that is just 5x. Okay, we're going to start with something simple. That's your sequence. Okay? Here's what you're going to do. First of all, I want you to press second and go to stat, second stat, and go over to where it says OPS. We're dealing with sequences, so as you can see, option number 5 says sequence. So select that. But here's the cool thing, like your calculator gives you this. The old calculators, you had to type it like this. But here we go. This calculators allow you. So the calculator is like, hey, what is your sequence? Let's come up with a sequence. Give me one sequence. 2x plus 1. Cool? Alright, what is the variable that we're using? Oh, sweet. Okay. Where do you want to start?
1.
The first term. How many terms do you want in total? 20. And because a sequence is the set of integers, right? We're going to go by 1. That's your step. And then you're going to say, okay, can you type this up for me because I'm too lazy to do it? And then the calculator's like, there you go. Okay, and then here's what your calculator is going to do. Here's what you just told your calculator. Listen, you told your calculator, hey, I have this sequence. I want you to find the first through the 20th term. Do it. Go. There you go. And the calculator's like, here's the first 20 for you.
Hallelujah.
I hope the test is like hell.
Okay? Alright, guys, do I need to show you one more time or do we got it?
Oh, can you
Okay.
The first one.
Alright.
Mr. Carrot.
So let's try the one where this one right here at the beginning, at the notes. You guys remember how we were trying to find like the first couple terms? So let's try number 2 here. Okay? Yes.
How do you find the rest of them?
Oh, then scroll down here and just keep going.
No, you don't scroll down. You just scroll down first, right? How do you do a summation?
Oh no. Paste the
Just say enter. Like, go to the enter. And you just can't move your hand.
After you move it, then you're going to have to retype it. So like once I'm out of there, like let's say I do something else. Like I can no longer go up and, well, yeah, I can no longer scroll. So at least select it again, hit enter, and then check your answers. Cool? Alright, here we go. We're almost out of time, so stay with me. Ooh, that made it worse. Here we go. Let's say we're going to try number 2. So what am I going to do first? Second stat, and I'm going to go to OPS down to, what is your sequence? So you want to type it just like it is. 2 minus parenthesis negative 1 to the, there's no n, so just use x, okay? What's your variable? X. Where do you want to start? Well, this one wanted the first how many? 5 terms? So 1 to 5. Go by 1. Enter. Enter. 313, 313. And there they go.
How would you do summation? Is that also?
I'm going to show you that next. Okay? Questions on how to find the terms using the calculator. Alright, then moving on. Now I'm going to show you how to find, let's do 18. First, you got to find the terms. Okay? Then, you got to find the summation of it. Cool? Now, here's my question. If you understood the properties earlier, what am I going to have to this for to include it on my sequence? Multiplied. So what is your actual sequence? 8n. So here we go. I'm going to hit second stat, right? I'm going to go to OPS. I'm going to go down to sequence, and your expression is going to be 8x. Your variable's x. You're starting at 1. And how many of these terms do you need? You need 5, right? It's up here. So 5. So everything else seems the same, right? So hit enter. So what are your first 5 terms? 8, 16, 24, 32, and 40, right? What is the total? Well, your calculator can save you a whole bunch of time. What's up?
Is the step ever going to be not
No, it's going to be one always for this class. Okay. For you to do the sum, yes, sir.
Couldn't you theoretically just do the sum, and on the inside of the sum, just put the sequence and just do it all in one step for you?
Oh, sure. You can do that, yeah. Thank you. Sure. You can do it that way too. Alright, so, guys, to do the actual summation, what's up? Can you do this for recursive? The answer I'm going to say as of right now, I don't know how to do it, so I don't think so, because it has a restriction. It's like, if this, then that, right? So I don't know yet. Let me look that up. I don't think so, though. Okay? Here we go. To do a summation, it's actually a lot easier. So if you do alpha, window, summation. Okay, so we're going from 1. So you got to type in the variable, though. We're going to use x. You're going to start at 1, and you're going to go to 5. And it's going to be 2n, right? X. But, hey, look, I forgot to put that 4 on the outside. Can I include it? You can go back all the way over here and do second insert, and then you can do 4. Enter. 120. Or could you have just done the following? Hey, I forgot to put the 4. I don't feel like retyping all this. I'm going to hit enter and then times 4. 120. What's up?
So, why, you know you can save an extra button press, right? If you just press math to 0,
To do what, I'm sorry?
if you press math and then press 0.
Oh, cool. There you go. Sweet. Alright, so do I need to show you 19, or can you guys try that on your own? Okay, so find the terms, find the total, and then try 20 as well. But 20 has a factorial. And I am telling you right here, I gave you the screen of where do you find the factorial. Where do you find this menu, by the way? It's right here. And there's the factorial. So find out 19 and 20. And then 21 and 22 we'll do together, and that's where we're ending. And we're running out of time, so at least find the totals for both of these, please. Tell me the totals for both of these. You got what, I'm sorry?
90 on 19.
So 19 was 90. Make sure that you can get 90. And the terms that I got, let me make sure. Does anyone have the terms? I got 10, comma 17, 26 and 37. Wait, but shouldn't I be getting 6 terms? Nope, because it's starting at 3. Check out where things are starting. So this is the 3rd, the 4th, the 5th, and the 6th. Be careful. Okay? Alright, the next one. It's not that pretty because of the factorial, but this is what you get. So 1,957 over 720. The first term is 1, the second term is 1, the third term is, the 0 term is 1, the first term is 1, 1/2, 1/6, 1/24, then I'm running out of space, but you can find out the rest. Cool? Okay. For the series, here's where they get interesting. It is going from 1 to where? Infinite. So this is telling you to find the infinite amount of this. But it's telling you to find the third partial sum. So that means that you need to find the first 3 terms and add them. The first 3 terms. So if you plug in 1 here, 10 to the first power is just 10, so you get 3/10. Plus, if you plug in 2, 10 squared is 3/100 plus 3. Okay. What's the answer to that? Well, if you think this through, this is like saying 0.3 plus 0.03 plus 0.003. So what's the answer? Thank you. Cool? Alright. For this sequence, find the third partial sum, but this time it's a 5 on the numerator. So what do you think the answer is? Well, let's try it. So it's going to be 5 over 10 plus 5 over 100 plus 5 over 1,000. So that's 0.5 plus 0.05 plus 0.005. Or what is that as a fraction? Does anyone know? 5 over 9. Alright, that's all I got for you today. The homework for this, it's on the Learning Hub. It's an actual worksheet. So we go in there and it says 8.1 sequences in series homework. Okay? Alright, I hope you had lots of fun with this. And don't forget about the Ghirardelli series.